Today, we're diving into one of my favorite ideas in all of machine learning, mainly because it's so beautifully simple, but also really, really powerful. It's called the K nearest neighbors algorithm, or KNN. Let's dig in and see what makes it tick.
It all really starts with a super basic question. Like, imagine you see something you've never seen before. Could be a weird fruit at the grocery store, a song you've never heard, anything. The first thing you ask yourself is, what is this, right? How do you even begin to classify it?
Well, what do? We look for clues, right? We compare it to things we already know. You check out its closest neighbors. It's that old saying, birds of a feather flock together. And believe it or not, that simple, intuitive idea, that's the entire foundation of the KNN algorithm. The whole thing is built on the assumption that similar things hang out together.
Okay, so that's the big idea. But how does this actually work in practice? Let's get visual and walk through how the algorithm votes to classify something new. Okay, check this out. We've got a bunch of data points here, and they're already sorted into a few groups. We've got triangles, and we've got pluses. Now, boom, a brand new data point pops up, this little question mark. It's a total unknown, and our job, our mission, is to figure out, where does it belong? So to figure that out, we have to decide on one really important thing first, and that's the letter K. Now, K is just the number of neighbors we're going to ask for their opinion. That's it. It's like forming a tiny little committee to vote on the issue. Are we going to ask the 3 closest neighbors? Or maybe 5? Or 10? That K value is the one thing we have to decide on up front. All right, so let's just say we pick K equals 5. What happens next is the algorithm basically draws a circle around our mystery point, and it expands that circle just enough to catch the 5 closest data points. So now, if we look inside our circle, what do we have? Let's count them up. Looks like we've got 3 triangles and 2 plus signs. Okay, so 3 triangles versus 2 pluses. Well, the triangles have it. They've got the majority vote. And that's it. Just like that, the algorithm decides our mystery point is now a triangle. It's literally just a democratic vote among its closest buddies. Super simple, right? Okay, but wait a second. I keep saying nearest and closest. How does a computer even know what that means? It sounds kind of subjective, doesn't it? Well, in the world of math and data science, closeness isn't a feeling, it's a number. It's something we can actually measure. Let's talk about how. So there are a few different ways to measure this distance. The one you'll see most of the time is called Euclidean distance. That's just a fancy way of saying the straight line distance. As the crow flies, the shortest possible path. Then you've got something called Manhattan distance. Think of it like a taxi driving in a city grid. It can't cut through buildings, it has to go block by block. And there are others, like Minkowski, which is kind of like a general purpose tool that can act like either of the first two. So KNN is great at sorting things, but that's not all it can do. This little algorithm is actually more versatile than you might think. It can handle a whole different type of problem. See, KNN is a champ at 2 main things. The first is classification, which is exactly what we just saw. It's all about voting. The neighbors vote on a category, like is this email spam or not spam, or is this a triangle or a plus? But it can also do something called regression. Instead of voting for a category, the neighbors' values get averaged. So if you're trying to predict, say, the price of a house, KNN would look at the prices of the 5 nearest houses and just average them out to make a guess. It's for predicting a number, not a label. And this super simple logic, it's everywhere. You'd be amazed at the places this birds of a feather idea pops up. Let's look at a few real-world applications where you'll find KNN working its magic. Okay, first up, recommendation systems. You know how your streaming service is freakishly good at knowing what movie you want to watch next? A lot of the time, that's KNN. It's not looking at movie genres, it's looking at people. It finds other users who have similar tastes to you, your nearest neighbors, and then it just recommends what they liked. Simple as that. Or how about this? The battery life indicator on your phone or laptop. To figure out how much time you have left, the system can use KNN to compare your battery's current voltage and temperature to a massive database of similar batteries. By looking at its neighbors in that database, it can make a really solid guess about how it's going to perform. And it gets even cooler. KNN is being used at the frontiers of science. For example, in biotech, scientists can use it to help identify the structures of proteins. By classifying different parts of a protein based on their known neighbors, they can figure out which areas are rigid and which are flexible. And that's crucial for designing new drugs. It's just an amazing example of a simple tool helping to tackle these huge, complex problems. So, if it's this simple and this useful, why don't we just use KNN for everything? Well, like any tool in the toolbox, it's not perfect for every job. Its biggest strengths are also kind of tied to its biggest weaknesses. Let's break down the good and the bad. Okay, on the plus side, the advantages are pretty obvious. It's super simple to understand and get working. It's versatile, right? It does classification and regression. And best of all, there's no complicated training process. It basically just remembers all the data. But that leads us to the downsides. Because it has to remember everything, it can get really, really slow when you have a massive data set. I mean, it has to compare every new point to every single old point. Also, it can get confused when you have too many features, something data scientists call the curse of dimensionality. Basically, when there are too many dimensions, everything starts to seem equally far away from everything else, and the whole concept of a neighbor starts to fall apart. But seriously, don't let those drawbacks scare you off. There's a great quote from the documentation of scikit-learn, which is one of the biggest machine learning libraries out there. It says, despite its simplicity, nearest neighbors has been successful in a large number of classification and regression problems. And that really says it all. Its simplicity is its power, and it often holds its own against way more complicated methods. And that kind of leaves us with one last thing to think about. The KNN algorithm is just this beautiful reminder that sometimes the most obvious, the most intuitive solution is also an incredibly effective one. It really makes you stop and ask, right? In a world that's getting more and more complex every day, when is the simple answer the best answer?